Problem of authorship identification of national language electronic discourse. And speaker Arnas Kapačius, please.
Okay, hello, my name is Arnas, and I will present problems of authorship identification of the national language electronic discourse research. And first of all, I begin from topics, and there will be a few sentences about the problem, authorship verification and attribution tasks, textual features, write prints and classification, then conceptual scheme of the system, support vector machine, one class classifier which is used in the system, then experiments and results, and final conclusions. And the problem. The internet provides a good place, a convenient platform for cyber criminals to do their activities. And like, for example, phishing and spamming, and also posting various illegal texts on websites, because, for example, many websites track only IP addresses, and even more websites do not track anything at all. So this is a very good place for internet criminals to do their activities. And in recent years, authorship analysis of anonymous texts in the emails, forum comments, tweets, SMSs received some attention in the cyber forensic and data mining communities. And authorship analysis, which is the research that we have done and still doing, is the study of linguistic and computational characteristics of the written documents written by known and unknown authors. So, textual features. Textual features are various components of written text which represent the writing style of an author, and they can be categorized into the character features, lexical features, syntactic features, semantic features, and application-specific features. And the features and feature groups that we used in our system, actually we used two groups. We used general features, which are language independent, and we also included the language, in our situation, the Lithuanian language specific features. And we, while doing the experiments, we separated these feature groups, and in order to explore how Lithuanian features affect the classification results. So you can see these are not all features and feature groups, because they would not fit into the slide. And these are only the main features. And actually together there are more than 2,800 features at all. So write prints and classification. Write prints are sets of feature number values, and they are used in classification. And classification can be achieved using various algorithms, mainly machine learning classifiers. Also, there might be similarity functions and various statistical functions as well. And this is the conceptual scheme of our system. And in the left scheme, it's the training phase of the system. And here, as you can see, it is difficult to see, but here in the upper component, here is the sample text of known authors. And then the second phase is feature extraction. Then we used dimensionality reduction algorithms. And we decided to use as many of these algorithms as there are classifiers, and in order to explore which of these dimensionality reduction algorithms are best working with classifiers. And then these reduced feature sets are passed to machine learning classifiers. Then the then the classification models are formed, and then there goes another phase in the right scheme, where the unknown text comes, and also feature extraction is needed there, and then the dimensionality reduction, which was performed in previous steps, the indexes of that reduction, which has been performed, are collected here and applied, and then there is a formation of a right print and classification. And as long as there are many classifiers, there will be a final decision module which decides the final results of all classifiers. And here comes the final results. So about support vector machine one class classifier, which is used in our system. It is this version of the classifier forms a decision function from sample data and calculates the decision function values for the test data, and then it compares these values. So the experiments and results. The experiments were done on 200 authors, and 80% on 20% text split was done, meaning that 80% of the text length goes to training phase and the remaining 20% to classification. And there were used actually two different experiments, as I mentioned before, the general and general plus Lithuanian language-specific features used. And as you can see, on the x-axis, here is the range of successful classification, the number of successful classification that fits in the ranges which are shown on the x-axis. And on the y-axis, there are the classification accuracy. And as you can see, the Lithuanian features, which are the red line, improved the classification results. And about which features are the most important of the Lithuanian features, there have been also done a few experiments while testing these features separately, and the results show that the most important are the ratios of frequencies of Lithuanian function words, stop words, and words with specific endings. And conclusion. Various techniques of authorship analysis were examined, multiple categories of textual features, as I mentioned before, and machine learning classifiers were chosen for the system, and experiments were done using general and general plus language specific, in this case Lithuanian features separately. And as I mentioned, results of the experiments prove that Lithuanian features improve classification results. So, thank you for your attention.
Please, question.
Yes.
You mentioned the one class classifier. Can you explain the one class? I mean, it's one class in not even classifier.
Yes, this is used for authorship verification task. I forgot to mention that the two main tasks of our research is authorship verification and authorship attribution, which are parts of authorship analysis study. And authorship attribution attempts to assign an unknown text to one of many candidate authors. And in this situation, one class classifier is not suitable, but in authorship verification that the experiments were done on, they tried to assign an unknown text. They tried to solve the problem whether a certain author wrote a given text. And in this situation, there's only one class needed, because the classifier is trained using only one author, and it only answers the question whether the author wrote that text or not. Actually, and it means
So I
yes.
understood that. As I see it, it's two class because it's true, it's broke, and it's not true not.
No, actually, it belongs to that one class, or it does not belong at all. So it is actually one class. If there would be two classes, it would be one class, another class, or no class at all. In this situation, it is one class, and it may belong to that class or not belong at all.
More questions?
Yes.
If you go back to the slide with the results, please.
Results?
I
Here.
was wondering, did you evaluate statistical significance between these results? Because you can see when the texts are getting longer, they converge to the same point, to the same result.
Yes, because as I mentioned, this is here on x-axis are range of number of results which fit into this range. So actually, as I mentioned, there were 200 authors, and finally all results, which here are 200, they all fit into these 200. So actually, finally, these two lines emerge. But in this situation, as we can see how Lithuanian features improve, because, for example, in the range of 10, the classifications with Lithuanian features there are more results which fit into top 10. So.
Okay, but the question was about if the results, let's say, having just one, okay, if those differences are statistically significant even here. I see that they exceed Lithuanian features by 1%, average around 1%, but is it statistically significant?
Well, it is difficult to say.
You haven't evaluated yet.
How much?
Yeah, it is difficult to say actually from these from this diagram, but actually the results, the actual results of the classifiers, the positions which classifiers show, like first position, second position, the Lithuanian features actually significantly improve the classification results.
More questions? Thank you. Next presentation, authorship attribution of internet comments with thousands candidate authors. Speaker, Jurgita Kapočiūtė.
Thank you. Okay, good morning everyone. So I guess that the people in this audience are working on the very different topics, so I will start with a short definition, and good that the colleague before me already presented a little bit from this field, but still. So let's go more into details then. Authorship attribution is the task of identifying who from the set of a given candidate authors is an actual author of a given anonymous text document. So, this is based on the existing human stylome notion, the persistent and uncontrolled habit to express thoughts in a certain unique ways. So, human stylome can even be added to human biometrics next to voice gate, keystroke dynamics, and etc. So, by the way, authorship attribution is one of the oldest computational linguistic problems dating back to 1887. But good thing that it is still highly topical nowadays as well. Of course, in the past, authorship attribution problem was more oriented to literary applications, to literary texts. But currently it drifts to more practical applications in forensics, electronic commerce, security. So if the research, as I mentioned before, earlier was done with the literary texts, so currently it is done with emails, web forum messages, online chats, internet blogs, tweets, and etc. So as you can see, the texts are getting shorter, and of course we have to deal with non-normative Lithuanian language or other language in general. So, of course, there are many related works and applications done for authorship attribution, especially on English. But summarizing all of it, we can say that currently the research is done with bigger data sets in terms of authors, so with hundreds or thousands of or even hundreds of thousands candidate authors. And here, the most effective and the most accurate paradigm is similarity-based, not machine, unfortunately, even not machine learning, but similarity-based. If we would summarize what is done on the Lithuanian language, so I would say that the concept of idiolect, the style of one person, was for the first time discussed in 1971. And everything started from these days. So from these days, lots of descriptive linguistic works were done. And we also can hear that there are other research done on authorship attribution. That is really nice. And there are, of course, we can say that we still lack the research done with the automatic methods. Of course, there are research done with the parliamentary transcripts, forum posts, 100 candidate authors, and machine learning techniques. So this is what I'm going to present in here. It will be a bit different because it is similarity-based method. But first of all, let's start from the corpus that we were using in our task. So we used internet comments crawled from internet portal Delphi, and the two subjects in Lithuania and abroad. Of course, we filtered out all the replies and meta information, and also non-Lithuanian alphabetic letters, let's say Cyrillic insertions, except for punctuation marks and digits. And we also used the texts that were not shorter than 30 symbols, excluding white spaces, because it's difficult to guess from this short text, even to attribute this text to any of the authors, because it's too short for the method to go with such a text. And since we had non-normative Lithuanian language, we had a lot of problems as out of vocabulary words, missing diacritics, and etc. It was spoken, let's say, non-normative Lithuanian language. By the way, how authorship was indicated? So we took IP address and pseudonym as one unique group to identify the authorship of internet comment. If the person with the, let's say, the same pseudonym was writing with a different IP address, it wasn't included into data set. So we collected the corpus containing 1,000 candidate authors, and we can see that it was about 35,000 of texts, and the average text length in tokens was 27. So it is rather short text that we had to deal with. And we also calculated random and majority-based lengths, the values you can see in the slide. So it was necessary that our method would exceed these numbers, because otherwise the method is doing nothing. So what the task that we were solving was that we had the data set of text documents, and we had classes, so the authors. And each text document was related, mapped into one class only, single class classification. So the goal of the method was to find that mapping, to approximate, to find the approximation as good as possible, as accurate as possible. But before solving this task, we transformed each text document into appropriate feature vector with the absolute counts of features. What features we used, I'm going to tell you a bit later. And we used similarity-based approach, as I already told, that because with the big numbers with the big data sets in terms of the authors, it is proved with English language that similarity-based approach is much more accurate. And we used Cousin similarity to evaluate the similarity between different texts. And we also used profile-based approach where all text belonging to particular author was concatenated to have bigger, to have more information about that author. And the final attribution decision was based on k-aggregated decisions by using randomized feature set. This is the concept proposed by Koppel and his colleagues. This is the pseudocode of the algorithm, but I'm not going into details because the core of this algorithm is actually similar to any similarity-based algorithm. Of course, there are some crucial things that I'm going to stop and to explain. Of course, if you are interested in, I can explain later, or you can read it in the paper about this method. So the feature set and different thresholds. So the main research directions of this method was the feature types. We had to identify which feature types actually work the best. Dimensionality reduction techniques, which ranks and selects optimal number of the most informative features, and different thresholds. So sigma 1 was responsible, as I already said, to evaluate if two vectors are similar enough. Because if they do not exceed particular threshold, it is said that they are not similar. And sigma 2, this is based on the aggregated decision where they had to calculate if, let's say, 10 of 20 times the author is attached to A1, let's say, and the other, that is 2 times by author, attributed to author A2, and etc. So we put some threshold saying that the attribution decision is enough to say that the anonymous text author belongs to particular, that anonymous text belongs to particular author. So there are the feature types that we were experimenting with. So the first is lexical. This is simple bag of words approach, the most common in text classification, so we had to evaluate it. It was lemmas, the most recommended feature type for the morphologically rich languages, as we know, Lithuania is such a language, and function words, different prepositions, pronouns, conjunctions, and etc. This is, by the way, the most popular feature type in authorship attribution because it is believed it is topic independent. And the fourth feature type was character tetragrams, by the way, word level. So successions of n characters within a token, sliding one symbol at a time. And here you can see the statistics about those features. Another research direction that I mentioned was dimensionality reduction techniques. There were 3 techniques. The first, no reduction. Second, ranking and selection of top n features. By the way, we used chi-square distribution for the ranking, since it is believed that it's the most accurate distribution for text classification for ranking the features. And the third is random selection of n features from the entire feature set. This is the experimental setup where we investigated those feature types, different dimensionality reduction techniques with n equal to 1,000, 5,000, 10,000, 20, going to 50,000. And we also investigated different values at thresholds, sigma 1 and sigma 2, as you can see in the slide, and evaluated F-score and accuracy. All accuracies and F-scores were averaged in 50 runs, testing 1 instances in each. And I have to mention that all 10 testing instances were, of course, eliminated from the corpus, because otherwise we would eliminate the same text instances that we learned from. And we used McNamara test to determine if the differences between the results are statistically significant. And here you can see the results, the impact of feature type, lexical features, lemmas, function words, and word level character and grams. So on x-axis you can see feature types, and y-axis f-scores in gray and accuracy in white. By the way, this black curve denotes the maximum of random and majority baseline values. And here you can see that the best results were achieved with character tetragrams, and the second best result was achieved with the lemmas, but the differences actually are statistically significant. It means that character tetragrams outperform the rest feature types. We also investigated the influence of diacritics. Since in Lithuanian language we do not have tools, at least effective tools that could restore diacritics in the text. So we went the opposite way by eliminating them from the text, because then our feature vectors becoming shorter, and let's say the evaluation decision becomes more robust. So as you can see here, the results were a bit worse, but not statistically significant. The differences were not statistically significant. We also investigated the impact of threshold sigma 1. As you can see, when the value is getting up, the accuracy is getting down, and f-score is getting down. This is the impact of dimensionality reduction technique. So the first two values of each n shows the top rank feature set, and the second two randomized feature set. So the best results were actually obtained with the entire feature set. But here we can see that even having more than or equal to 5,000 features, the results were already not statistically, the differences were already not statistically significant. So, of course, shorter, smaller vectors means that, as I already said, that we have more robust evaluation and of course, more quicker. This is the impact of threshold sigma 2, and again, the situation is the same, as with sigma 1, the value is getting up, the results are getting down. So it seems that it's sometimes better to have even wrong decision than not to have any decision at all. So summarizing everything what I already said, I can say that results exceeded random and majority baseline, so the method was useful, was effective, and the best feature type was character tetragrams, then lemmas, and at the end, bag of words. The question would be why lemmas were not so accurate? Probably because we were dealing with not normal Lithuanian language. So, and a lot of words were even not recognized in the text because they were out of vocabulary or they were without their critics. And function words gave very low results because the texts were very short, and they were very rare in the texts. And the results with diacritics were better. And here we can say that the choice of author to choose to write with the diacritics or not is, again, denotes his own style. And even a poor similarity in terms of sigma 1 makes already positive impact. We wanted actually to narrow, to decrease this value, but it seems that with such a difficult task, when you have 1,000 candidate authors and such short text, it's impossible to make positive impact. And the best results were achieved with the entire feature set, but randomized feature sets with n equal or more to 5,000 or top-end features with an equal or more to 30,000 reach very similar performance levels. And even disputed authorship attribution decisions already make positive impact in terms of sigma 2. The conclusions would be that this is the first authorship attribution results for the Lithuanian language with such a big data set in terms of candidate authors, with internet comments as well, and with a similarity-based approach. The results, well, they are not shining, but still we exceeded baselines by more than 10%. And in the future work, we are planning to make error analysis, which could make us to improve the accuracy. We also plan to expand the number of candidate authors and to experiment with other similarity measures types of non-normative text that was recommended by reviewers. So, thank you.
Thank you.
You mentioned that you couldn't use many lemmas due to the language that is used in comments. Have you considered using spell checkers or something like that to improve text of comments so you would get more lemmas out of them?
Yeah, we haven't. This is interesting remark, by the way. But again, if you have many levels, let's say if you have spell checkers, if you have lemmatizer, at each level you have errors. So I can't say that it would actually really improve the overall accuracy. So, but yeah, your point of view is interesting. Thank you.
More questions?
Have you tried comparing your results with let's say, a different classifier, for example, a machine learning based approach?
Not yet. We are working on it. It would be interesting to say for the Lithuanian language as well if similarity-based approach is outperforming machine learning methods. But we unfortunately don't have these results for now.
Thank you. And next presentation, Lithuanian digit recognition by using hybrid approach by combining Lithuanian Google Recognizer and foreign language recognizer. Speaker Tomas Rašinas, please.
Simas. Hello, I'm Thomas, and today I want to present you my and my colleague latest work is Lithuanian digit recognition by using hybrid approach by combining different speech recognition engines. So it's well-known fact that speech recognition based interfaces could be great value in many applications. Particular benefits could be achieved by disabled people or people who are working in some kind of area where huge degree of freedom is needed. Digit recognition is common task for many applications. For example, person ID code recognition, phone number recognition, and so on. The development of such a speech recognition system requires enormous resources. It's human resource, time, and money, of course. So it's difficult. Big companies like Apple, Nuance, they are not interested in developing such a recognizer for those not so popular languages. So there are few options. You can create recognizer from the scratch, but it's very time-consuming thing. And on the other hand, we can take already trained foreign recognizers and try to adapt them for our needs.
So there were some studies that shown that English or Spanish recognizers can be quite good adapted for Lithuanian language recognition, but of course not always the results are as good as expected. So it's natural to try to combine these recognizers and create the hybrid one. In other words speaking, we can take not all, for example, 2-3 foreign recognizers and adapt them for Lithuanian language recognition. The main approach of hybrid speech recognition system is parallel use of different recognizers. So the main objectives we want to analyze possibility to increase Lithuanian language recognition accuracy by combining multiple foreign language recognizers. We wanted to evaluate the methods that can be used for such a task. Also, we evaluated Google Recognizer, which was introduced this year, and analyze how good adapted foreign language recognizers can recognize the Lithuanian language. So the architecture of a hybrid speech recognition system is displayed here. We take speech signal from microphone. We pass this signal parallel to all recognizers we were using. Then we take output from recognizer. It's recognized text and hypothesis score. It's the score of how well audio matches the model. And we take only one best score. And then the information is passed to train the classifier, which makes a final decision. Speech recognizers that were used in our experiments are these: English, Russian, and German, taken from VoxForge. It's open source acoustic models, and one German was taken from Darmstadt Technical University. And of course, we used Google for Lithuanian language recognition. These they were selected just because they perform quite well in real-world applications, so we wanted to test them in this kind of experiment. Of course, if we want to use foreign language recognizer for Lithuanian language, we have to adapt them. Adaptation was done by using transcription rules. We took Lithuanian commands and using foreign language phonemes, we rewrite them. And this, as you can see, these transcriptions is quite simple because we wanted to evaluate the methods, not the adaptation process. So corpus was created of 10 digits names, it's from 0 to 9. We recorded random people who want to participate in this experiment. They repeated comments and we recorded them. We had 79 times it was recorded, and 1,000 recordings were used for classifiers training and 790 for testing. First of all, we tested single recognizers. As you can see, results are not so very good. Some recognizers, for example, German first shows very bad results in recognizing command 2, 3, 4. Google recognizer shows very bad results in recognizing 8, and English, for example, in recognizing 3 and 4. It's very interesting that Google shows such a bad results in recognizing number 8. So we looked in misrecognized words and of Google Recognizer, and we saw that it's there are a lot of not a lot of some English words in Lithuanian language recognizer which were misrecognized. It's, for example, Ryan, video, Fishki, and so we make a prediction that Google used English recognizer. They gathered some Lithuanian recordings, and that and the trained English model. And what is more interesting that we found that when we say command 8, Google always returns game site ya.com. So we think that it's influenced by the search results. Average accuracy of every single recognizers is displayed here. As we can see, English shows quite good results at 85%. All others show also accuracy about 80%. Then we calculated correlation between every adapted foreign language recognizers and a recognizer that had biggest correlation differences were combined, and we tested different combination of these recognizers with selected classification methods. And as you can see, best results were acquired when all 5 recognizers were used with a naive bias classifier, and Russian, English, and Google was used with linear discriminant analysis classifier. So all other results are also quite good. It's about 95%. If you look at average accuracy of combined recognizers, we also see that best results were acquired when all recognizers used, or when English, Russian, and Google were used. So German recognizers don't perform not very well in this kind of experiment. If we looked at the classifiers that we were evaluating, we can see that naive bias classifier and quadratic dynamic analysis showed best results. It's quite interesting because naive bias is such a simple classifier and it performs such well in this experiment. So we think it's because of data, because for testing and for classifiers training we used not so very much data. So as we know, naive bias needs not so much data to calculate the parameters needed to classify. And comparing combined and single recognizers, we can see that the hybrid approach shows better results in every command recognition except command 3, where Google perform better. But we think that it's because we used only single best hypothesis from every recognizer. So we think that because that in the future we're thinking to take 2 or 3 best scores and try to repeat experiment. In conclusion, I can say that our researchers show that it's quite reasonable to combine the speech recognizers in order to increase recognition accuracy. We achieved 97.5 accuracy in Lithuanian digit recognition. That means we increased accuracy compared with single recognizer by 12.6%. And best results were acquired when naive bias classifier was used and all foreign language recognizers. So, thanks.
Please, question.
What is the performance of all recognizers running in sync, in async, whatever mode? How much time does it take?
It takes lots of time to load the data, but when it
How much is lost?
I can't tell exactly what the time.
1 hour, 2 hours?
No.
10 minutes?
No. For this example, to load all the data, 2-3 seconds. For recognition, second.
To run all the engines in parallel?
Yeah. I tested with 5 engines. So, of course, using Google, it has to make a call to the web service, so it takes a little bit longer. But with local engines like foreign, so it takes a second. I exactly didn't evaluate that, so I'm just saying how I remember.
And which platform was chosen?
Windows.
Windows.
Yep.
Why?
I don't know.
Since I imagine most of the Voxforge based were probably Sphinx, yeah?
Yeah, yeah.
So
Pocket Sphinx.
maybe it's easier just to run from Unity. No?
I don't know.
Faster? Okay.
More questions?
What is the problem with Lithuanian language recognition, and why can't methods from other languages be used for Lithuanian? Why not make a Lithuanian language detection, or rather use some combination of different language based approach?
Because if you want to have Lithuanian recognizer, we have to gather lots of recordings, and it's the hardest part. And it's lots of people, we have to participate, we need a lot of money and so on. Of course,
We have another one. Have you tried logging in and using different Google account?
no.
Maybe the
I
results
want
will be
to say that,
completely different
mm.
if you got the sites you're visiting.
Maybe it's
Or
possible.
just create a new one.
Yeah, it's possible. Yeah.
I have one. So in practice, how that combined approach actually works? Let's say we have 5 recognizers, and we say 8, 8,
Yeah.
and 3 of them gives us bad results. Let's say they didn't recognize it, and 2 give correct.
Mm-hmm.
So what's out of this?
So all the predictions are made by trained classifier. So every result of these 5 recognizers form a feature vector. We take best hypothesis score and train with that feature vector we train classifier, and then classifier predicts which recognizer to choose, which recognizes a result to choose.
And what if the incorrect result, the probability of it is high enough?
So
then you
classify.
have a false positive.
No.
Why not? If, for example, you said 8 and the recognizer outputted like 2 or whatever, something else, but he gave you a probability that this is 0.9, for example, which is very fast. And let's say the German recognizer outputted 8, but the probability was 0.2 or 0.1.
So this task is for classifier to learn how to learn the data pattern.
And is it reliable?
97%.
Yeah, like so.
Okay.
The probability is at 95 or 7%.
Yeah.
That this approach gives positive.
Yeah.
result.
Do you have some statistical evaluation? Like, is it reliable?
We have the results.
Yeah, but what is the deviation, for example?
No, we didn't calculate the deviation.
Because it might be correct with a given data set, but statistically with a larger set, deviation might be higher, no? I
Okay.
think in next time on your work, you should just calculate it.
Analyze the-
Gives you some insight if you're working towards the correct way or not.
Okay. Thanks.
What is the practical value of your research?
Practical value is that we can create isolated command recognizer with very quick and cheap.
Did you can tell that after this training on 10 digits, you can use this for other words?
No, no.
So
It's it's in particular that case we can use for that command recognition. If you want to use for other commands, so you have to retrain everything.
So the question was, why did you don't create Lithuanian recognizer, even using?
For all the words, because isolated commands recognition sometimes is enough to have this kind of recognition, good recognition, to achieve end user satisfaction. So, because it's yeah.
Thank you. Next presentation. Ne tokį?
Ne, patį. Tik Julius kojas susilaužęs. Tai.
Next presentation, text predictor for Lithuanian language. Speaker Rytis Paskeliūnas.
Good performance. Hopefully it will work. So while this loads, I will probably introduce the talk. This will be about text predictor made not for a typical standard user who has normal speech capabilities, but for a disabled user. So it has some peculiarities in it. Okay. So I imagine most of you are familiar with the predictor itself. It's often installed on a modern smartphone, even in a not so modern smartphone. So whenever you type a set of characters, it gives you a imaginary prediction of what word would this be, and depending on the quality of the model itself, it can be either very advanced or just predict what this word is. So since most of the users which the predictor was aimed for in the study are not very healthy, and this was developed especially for the patients with Huntington disease, which is, for those who don't know, is a complete nervous disorder. It's a genetical disease, and with more and more serious stages, the nervous system is deteriorating, and he is no longer able to formulate sentences like a normal person is able to, like a healthy person, and is no longer able to speak, and he's also no longer able to fluently produce a command. So a standard system, which mostly is effective in giving a prediction of a specific word, is not very effective in this case. So we thought actually to make something that is a bit more advanced and might be able to grasp the context of what a user might be willing to tell you. So for this purpose, we have made a custom predictor, while in principle it is not very unique, but as a solution there are no similar alternatives, because the majority of the predictors we have evaluated are aimed at a completely normal person with normal health levels, normal thinking levels, and normal way of inputting whatever is necessary. So this system, of course, allows to greatly enhance the performance of the text input rate. I will not talk about the performance part itself, because the performance was not yet evaluated. But basically what we need to do is to predict next block of characters in one case, and also to predict a whole word, and also maybe to suggest the next word, or in an ideal case to predict whatever sentence he's trying to tell you. So in medical applications, a doctor often has a questionnaire and tells you, like, blink if you have a pain, blink if the pain is in the upper part of the body, blink if it's on the left side, and blink if it's in the heart area, is it a strong pain, blink if it is a strong pain, and so on and so on and so on. And of course this is not a very effective solution.
Why it is so? Because, as you probably imagine, there's not much time given for the patient to produce the outcome, and of course the health system overall is too busy to like spend a couple of hours just to find out what it is. So, as it is an often case, it just the patient is connected to some analysis apparatus and just measure their heart rate and so on, and just basically given a basic treatment. Not trying to find out what exactly is the problem, because he's no longer able to produce what is the problem. He's no longer able to speak, he's no longer able to write, and of course, in some cases, in the worst case scenarios, he's just moving like this, so not able to like produce, press a button or something. So the system for this task has to be multimodal and as well multilingual. But this means it must be trainable on whatever language the patient is. So this is not the biggest part of the issue. The multimodality part is one of the major issues, but this is probably a talk of another topic. Back to the text predictor, we have chosen a Presage-based system, which itself is open source, has some research done with it, so you have some background, what is, how to use it, what are the probable results, and so on and so on and so on. So, as you can imagine, the typical input, you have a virtual keyboard. The most often case of producing this, the input is blowing into a tube, or in some cases where he's still able to blink willingly, is blinking into a camera and detecting this movement. So, and the system itself moves automatically from one letter to another, and just like a virtual normal keyboard. So, as soon as we have a set of characters, or one character, or maybe more than one, or a word, we try to give something back to the user. So the output is naturally a list of predicted words, those suggestions, and these suggestions, of course, should somehow detect what a user is trying to tell you, and not give him like 5 or more words to choose from, because this is not good performance and not very good effectiveness, because he's not able to, the thinking part is also a bit damaged, so the less choices, the better. This system was developed like a plugin, so, and this allowed a complete integration of it, like we can have 5 predictors running simultaneously and so on, or integrate it as a service, or whatever is necessary for the specific input task. And system allows doing semantic prediction, which is very important, just detecting what context is. We don't have much research yet on the semantical part, but the rest, like statistical prediction on the which is the most often used word, letters, in which case it is most often used, and so on. This works quite reliable. Also abbreviation, expressions, repeating predictions, and so on. This is integrated, and I will not talk about it in detail because this is mostly classic algorithms, and they're not unique in itself, but they add up to the overall performance, of course. Okay, so we also have multi-user profiles, but this is probably obvious. So as each disabled user is very different. So, okay, not very good quality, but as you can imagine, in the top is the engine itself, which is the pretty standard Presage code, pretty standard algorithm. The main part of it was not modified, but the rest of it was adjusted to suit our tasks. I don't have, does not matter. So we also have an option to inject some plugins, to introduce some specific add-ons, some specific processes, and so on. And we also have a history tracker. So in this, learning system is connected, so the system is able to train itself as the more user speaks, so the better is the performance of it, and so on and so on. So it's also we have a combiner to combine multiple outputs to produce like a suggested sentence or a suggested word and so on. Then we have a predictor to trying to predict what the user is saying, but the scheme, in my opinion, is pretty obvious, not very unique, but it works quite effectively. Okay, so it is integrated into a specific part of multimodal user interface with the goal to give a patient with a Huntington disease symptom a way to express himself, because there's a very large problem as the number of patients is quite low. No medical research is done, and they're treated like a typical patient with mind disorders. So it's an adrenaline injection, like restraints in some cases and so on, but the overall number of patients is around 20,000 in Europe. So the pharmaceutical companies, universities think the number is too small just to concentrate the research on how to cure this disease. So at the moment, disease is incurable, and there's no absolutely whatsoever softwares, hardwares, and produced for the patients with Huntington disease. So the system has GUI, which is projected into the area the user is looking at, and depending on the level of disability, he's able to use gaze recognizers, speech recognizers, suck and blow, controllers to blow on a tube, also additional readers with EEG, but this is not very reliable. But all of this must be integrated and connected to the text predictor to determine what he's trying to tell, because otherwise he's not able to speak, and in most cases he's not able to raise his hand, this is okay, or blink and hold if it's a yes. So it's just like this. So it's very hard to guess what is the problem, but by combining all of those, this is one way of doing it, but it's also probably part of another talk. So for the training, Julius went probably the easiest way. He picked freely available Lithuanian books, electronic versions, which I imagine one is able to use however he wants, and use that for training materials, just to see, not from the usability point, but just to see if the system is able to work correctly. So the training set was 30%, and the test set was 70%. Of course, we could do the opposite and use a larger part for the training, and then the smaller part for the evaluation. But a problem, maybe not a problem, but an advantage of the Lithuanian literature is the large differences in writing styles and languages and so on. So a specific section of each book of each different author was split into those percentages and fed to the system, just to see how it would work with different language styles and so on and so on, so the effectiveness of it. As those familiar with predictors know that it's most often some statistical engine inside of it, so, and can be HMM based, can be like a simple statistical search and so on, but in this case, I suppose this is pretty standard 3-gram model, and inside it also of course contains 2-gram and 10-gram models. So we also evaluated some different ones, but later about that. Just to give you some numbers, some unique records, and I'll go to the main results. This is a work in progress, and I just do the consulting part of it, but this is the curve of the performance. In my opinion, maybe not a completely new one, but somehow obvious,
in this y-axis we have total percentage of characters, so how much we give. And in the x-axis we have a number of suggestions per prediction. So in ideal case, of course, we want to give as small number of characters as possible and to get back as small number of predictions as possible. So naturally, how it works, like we type like one letter, we have some suggestions, we type 2 letters, we have less suggestions, we type 3 letters, even less suggestions, but this is probably obvious. We are reducing the number of possibilities to choose from. So what I personally was interested in, so this is not a direct curve, and it is possible to find some optimum. Also, personally, I'm not very interested in the prediction of the word itself, but in the prediction of the sentence. So this is, in that case, of at least pairing a couple of words and to give you the output of some context now. Like, I'm writing chest, so the obvious would be pain, since this is a medical case. Like, this is just an example, but we are mostly interested in the performance of some combinations of words and not just predicting the first word, which a standard predictor with some training is able to do sort of well. So this is the result curve, and as you can see, it's sort of, I don't know if it's good or not, but a reduction is possible, like to have 3 or 4 suggested words, which are sort of in context, not completely different out of this mind words, with reasonably small amount of input. And naturally, this is sort of artificial, but we have 2 patients. One is in the very serious stages of the disability, and the other one is in the beginning stages of the disability itself. And the good thing that practically it's sort of usable, but depends on the state of the person itself, because in some states he can jump into uncontrollable stasis, like he's just moving sporadically. Probably we're not sure if at that moment he's able to think like a sane person would, but the view is that he's not controlling anything. Medical staff, he has like 1 year to live. He's deteriorating, and as you can imagine, the whole organism shuts off. He's not able to serve himself. More results. So we have tried to see the performance of that. This probably was due to of the researcher doing it, but the performance actually was okay. It is actually hard to find optimal ways to give system for each cardinality class of the model, and the relatively high input of course relates to level of inflection in the Lithuanian language. Since our language is, I don't know, considered kind of difficult, the first part of the word can be the same. The ending of it could change the meaning completely, especially in the sense of a context. House, which is namas, and we could be in the house, name. So the context, I can just It is sort of a problem for a computer to introduce and to have to determine the semantical value of it. So this is different parts of the roots and different. We're able to guess. Thank you, and please.
Just to make sure that I correctly understood, given the first few words of a sentence, you are trying to predict the next one, yes?
Yes. So the first hit would be implicated in the overall number of searches. So might not in a sense of practical. And this is actually quite easy to find if you are switching the same word, type the same two words, and the results often will be completely different, even if I'm logged in with the same account. Since I travel a lot, I have noticed this factor.
So there could be you like different Google.
Yeah, that
Then do a
Some combinations could be quite easily predicted, especially if we take into account a problem domain and so on. But other words and their use in certain combinations are quite difficult to predict. So do you have some classifier or whatever just to classify different words, or how does this algorithm work?
sort of a classification was introduced to it. I cannot give you much details, so you have to contact Julius on that because he did that. But as I know, the effectiveness of it was not very high. Medical entry of the patient, because as you imagine, a sane person is starting with pain, ache, and so on. But in his case, he able to train itself depending on the inputs and able to select and so on.
No more questions? Please accept.
Some paper. Thank you.
Next presentation, first steps in automatic ANOFRA resolution into any language based on
Hello, I'm Valdemaras, and I will be speaking about anaphora resolution in Lithuanian language. So first of all, amount of information available is increasing rapidly, and it's becoming physically impossible for us to analyze it. More and more relevant. Unfortunately, most of the work has been so far
major ones like France, Germany, China. Is one of such areas that hasn't been equivalent relationship between each other. Anaphora in this is a relationship when one interpretation of one school today, he was sick. In this case, he and Tom form some relationship where he is an object and Tom it's an why Tom was sick. Goal of the research is to create a basis that could be used for to reach this goal. We divided 5 tasks. First of all, to analyze anaphora resolution methods available for other major languages, develop new ones suitable for Lithuanian language, implement them, conduct experiments, and evaluate their performance with precision and recall as main criteria. First of all, research is being done in the framework of semantic search project. And this is context diagram. Relevant bit is at the corner where anaphora resolution sits between linguistic annotations and semantic annotations. Related works from other languages have been, 7 of them have been selected as examples. There are many more, but these 7 represent different directions that can be taken to solve this problem. So we can use syntactic trees to navigate the sentences, centering theory, salience, statistical machine learning, universal, which divides sentences into graphs and forms relationships. Very accurate because each method usually solves only a specific subset of vastly different results. That can be used for this task, therefore it's hard to take anything specific. The preliminary ideas of this research was to create a taxonomy of create suitable solution for the process. We take text morphological annotations, named entity recognition. At the time of research, syntactic annotation wasn't of sufficient quality. Is also made based on the results of semantic annotations. The purpose of taxonomy was to extend in order to better cover where semantics and domain semantics. The morphological is based move back one sentence. I mentioned semantic search framework. Usually don't have many named have possibly to further works in this field have been done towards coreference resolution, and as seen in the previous principal schema, it is done after semantic annotation. Here we take all entities that are equivalent and form relationship between them. It is done intertextually, meaning that while anaphora resolution is done in the borders of one text, coreference resolution can be done between different texts. So we know that, for example, the Grybauskaitė in one text is the same entity as the Grybauskaitė in another text. Algorithm so far is rather simple. It takes named entities and runs their similarity based on the rules against other entities. If similarity is made, then relationship is created. If not, we move to the next one. And experimentation was done on the slightly different, smaller corpora. And it's difficult to evaluate precisely, but we managed to decrease the unique individuals from 3 million to around 77,000, which is a noticeable improvement. But as mentioned, we currently do not have developed tools that would allow us to evaluate precision and recall, which is likely that we made some mistakes and didn't notice some possible coreferences. So in conclusion, research is still relatively in early stages, and so far we have created mentioned taxonomy and basic algorithms for anaphora resolution and just shown coreferences. The main benefit of this approach is that it needs relatively not many resources, which are considered cheap, because if we are doing natural language processing, we are going to have segmentation, we are going to have morphology, otherwise we wouldn't be able to do anything. It provides suggested algorithm that has comparable results to the other methods of other languages, but as mentioned, it works on the very specific type of texts and solves only a very small subset of anaphoras. And the future work is directed towards creating more sophisticated anaphora resolution methods and trying to solve some more of the coreference resolutions. Thank you for your attention.
Question? No question? Thank you. Yeah, presentation? That's all. Thank you.
For a certificate of appreciation for the chair. Our second keynote presentation by Dr. Tarkan Gürbüz from Middle East Technical University, who will deliver his presentation on learning environments supported by social network platforms.
Good afternoon, everyone. I hope you have enjoyed your lunch. It's a great pleasure for me to be here with you, and I would like to thank the chairs and committees of the conference for their kind invitation, and special thanks for Danguale Rutganskiene and Robertas for their effort to organize this conversation and beautiful conference in beautiful city. A special thanks also go to the local organizing team for their successful preparation for us here to present our topics. As you already follow from the news, we've been through very difficult days in Turkey. Many people died during the bomb blast in Ankara, where I live, and many people died in some other cities of my country because of terrorist attacks. In spite of the sad times, I look forward to coming here and being with you to share what I think is worthwhile about my topic. So today I will talk about learning environments supported by social networking platforms. Before I go further, I would like you to feel free to stop me at any time during the presentation, ask your questions. Please do not hesitate to stop me. And I hope you don't feel sleepy after so much delicious food. As Marcin mentioned in the morning, that we don't have the censor's chair, and so I hope you are going to be with me during the presentation. So I had my bachelor degree in mathematics, and then I decided to combine what I know about computers and mathematics and combine it with education, and I discovered the field of instructional technology. I continued with my PhD studies, and during my PhD studies, I was engaged in different projects and trying to understand the business world, because we were dealing and associating with different companies. And then I went to Italy for my postdoctoral studies, and I had the chance to do an MBA there. And after having an MBA degree, I turned back to my university and started to work in Middle East Technical University. So I'm an instructor in my university, and also I would like to introduce you about GDLN, Global Development Learning Network. I will give you a brief information later. And I am also the representative of Europe and Central Asia region. So you can contact me through this email address. Please try to keep in touch with me later on. About my university, I would like to say that we have 5 different faculties, and we are leading university in Turkey and trying to be also leading university in the world. And we are at the top ranking lists. We are an international university, and we have different collaborative projects with different universities all over the world. And my department is focusing on innovative research on learning with new knowledge media and trying to understand the development of innovative learning environments supported with instructional technology. And about my country, I can say that it's like a bridge between Europe and Asia. Lovely cities. Is there anybody who already visited my country here in this room? Very good. So you can tell more about Turkey to others during the coffee break, and you can share your experience with me. I would like to listen to you. And I know that in the region in Lithuania, Trachea region, I guess, also there are Karya Turks and if I remember wrong, yeah, Karay Turks. And is there anybody who knows that village? Turkish village in where Karay Turks live? No, nobody. So this is an information, new information for you. And about GDLN, I can say that this is a network of members dedicated to share what they have in terms of knowledge sharing activities. And it is a partnership initiated by the World Bank and at the beginning of 2000. And we as Matthew started to work together with those partners from 2006 till now, and this network is becoming more and more powerful all over the world and trying to attract new partners from different countries and different institutions. So you are also more than welcome to get more information from me, and from Danga also is a member in this network, and we collaborate very well in the network. So today's agenda includes a brief introduction, and then I will devote some time to understand the change, because we are living in strange times and the world is changing. So we will touch to this topic a little bit, and then I will continue with talking about learning environments and social networking platforms, and then I will try to end up with results and recommendations. And of course, I will wait for your questions, and we will have the chance to discuss more about the topic. So the program allows me to talk for an hour, but I'm not going to use all the time. I will try to devote some time for questions. But during the presentation, you can also ask your questions. Please don't wait for ending the presentation. So if we say, what is going on around the world, around us? If you try to look from different perspectives, you will see that the world is changing with a high speed. And today's reality, in fact, indicates changes in a number of key areas. What are those key areas? We say that school change. I'm talking about student change, teachers change. So the roles are changing, and we are talking about learning environments, rich learning environments, where students, learners are at the center. Learner-centered education. I have this picture, and a very old picture from the date 1907. And this is a classroom in USA at that time. And this picture is taken in 2005. As you see, there isn't so much difference in terms of environment. The desks and students, teacher, blackboard. And this is a typical classroom. Also, this is a typical classroom. When you think about those days that computer became a part of our lives, in different sectors, in different industries, we observed enormous change, suddenly, very quickly. In banking industry, let's say. When you go to banks, you talk about online banking now. You use internet very much. And for the business also, those technologies were integrated very quickly. But in education, this is not so much quick. This is very slow when you compare with other fields. And now we have the computers changing the learning environments a lot. There is a relationship between knowledge, change, and learning. Is there anybody who can help me? What is your opinion? What is this relationship? Any volunteer? Knowledge, change, and learning. Whenever you learn something, don't you think that you change, you are different, right? It's something like that. And whenever you change, what happens? This is the relationship between learning and change. Learning will provide the new knowledge necessary to deal with the demands of change. So you are trying to adapt yourself. Like in the morning session, we mentioned about who moved my keys, change management issues. And you have to be quick enough to cope with the difficulties of today's difficulties. So we are observing a knowledge-based transformation. Transformation, it's not modification, it's not something else. Transformation is huge change. You change totally everything. So this knowledge-based transformation created some needs. New organizational structures to cope with the difficulties and new educational settings in order to cope with that enormous speed of change. And new thresholds for research and development. And of course, this change changed how we learn. So in knowledge society, we are trying to develop knowledge society. In knowledge society, we are looking for different pedagogy methodologies to help students to be more active, integrative, creative, evaluative, and more collaborative. So this is the core activities that we are trying to modify in our educational systems. And those developing technologies, especially internet technologies, helped us to develop online collaboration tools and online learning environments. Those technologies enabled us to collaborate more and more and communicate with others easily. If we talk about social media and social networking platforms, I'm sure many of you will say that you use Facebook and other social media and other tools, and mostly you can associate those technologies with procrastination. You lose your time a lot. You share whatever you have, and you try to follow others what they have already shared. This is sometimes time consuming, but you cannot avoid those technologies. And you cannot avoid that your students are using the technology. But you have to be sure about their potential for collaboration, for communication, and their potential to motivate your students. I will talk about those issues. So they provide discussion forums, different technologies like blogs, wikis, and 3D virtual worlds. How many of you have already tried Second Life in this room? Yeah? Would you please share your experience? How do you find Second Life? No, not you.
No, but actually quite unspectacular. So mainly you just walk around and see clumsy looking avatars, and there was not much happening. So
okay.
It was not an exciting experience. It was like missing, why the hell does it have to be in 3D?
Do you have your own avatar there?
Yes, but I didn't spend enough. I did not spend much time.
You didn't discover the world yet. It's a virtual world that you can have your account, and you can borrow some land, you can build a company, you can organize conferences, and there are real conferences going on, and they use Second Life. I don't know, in the future, we have very interesting predictions. Like again, I would like to remind you the predictions that we mentioned in the morning session. Future is waiting for us, and we are trying to shape the future for our needs. But technology is sometimes out of control, and I don't know, it's not easy, it's not really easy to predict what will happen. So the recent trends remind us the potential of those technologies to offer some more collaborative and some more creative environments. But the most important thing here is we develop different solutions for distance education and distance learning. But those new technologies really introducing more innovative approaches, especially for lifelong learning purposes. We are very sure about the number of people who needs more education will increase. Not only for traditional education. People who are working, they need to refresh their knowledge, and they have to attend some more online courses. That's why online courses and e-learning is becoming more popular. And it's a growing industry. And this picture is not very good quality picture, but you can see the auditorium full of students, but all of them have got their laptops on their laps. So while they are listening to you, while they are attending the classes, it's very familiar in my university. Everybody has their notebook. They either take notes, or if you go and check, they are mostly communicating with others through social media. Because we don't allow students to use their mobile phones, so they use the laptops for their purposes. So why not to use this environment for learning purposes? Be careful. You have to, of course, establish the necessary mechanisms to motivate them, to engage them. Otherwise, it's going to be an open channel for them for procrastination. And they will be far from learning purposes. And the research, we can say that in order to see the big picture and to find answers, to develop innovative learning environments, we have to focus on those potential new technologies and how we can use them as learning tools. If we mention about learning environment, it reminds you the ecosystem that students, learning materials, instructors, and the environment is full of different resources. So the power of the technology is it offers you possibility to combine, to create new channels and to control. But the most important thing is you have the data. Data to analyze. Because whenever you are in the environment donated and supported with technology, you talk about databases, log files, and recorded information, and full of information that you can analyze. And believe me, this century is going to be the data analysis century. If you have the power to make good analysis of data, then you can shape, you can guide others. And if you have the good working system, then you have the chance to establish the human resources for the future, because you can follow each activity of students and you can elaborate on the data and then see what you need to improve by looking at the population. And you can combine it with your future needs. I would like to mention here a report published by OECD, and this is an interesting project. Gathered 125 examples from more than 20 countries and includes case studies. OECD's Innovative Learning Environment Project. Have you heard about that? Is there anybody in the room? This is a quite intensive project and intensive report. If you have any chance, it's published and available on the internet. You can look through the report. And I find it very useful because by looking at the results, you can find promising suggestions and recommendations how you can build learning environment in your university, how you can establish innovative learning environment in your institution for the people to learn effectively. Because we are now talking about just-in-time learning, not just-in-case learning. Before, we were trying to donate the students with necessary knowledge and information, just in case they may be an engineer, or just in case they might be a medical doctor, so full of information. Like in the manufacturing, just-in-case production. Now we talk about just-in-case learning. Not just in case, but just-in-time learning. So whenever you need something, necessary information is going to be delivered, and you will learn, and then you can use the information for learning purposes, and you can produce the solution very quickly. If you look at the results of that report, one can think that a contemporary learning environment should have some characteristics. Those characteristics, of course, should promote 21st century effectiveness through the application of the innovative learning environment learning principles. So we talk about some principles that you should underline. And those innovative learning environments also provide blended learning solutions. Blended learning is not somehow you blend everything and then a bit of this, a bit of that, and then you have a solution and provide it as a learning environment. It's not like that. When you talk about blended learning solution, you think about the best size, best solution for e-learning, and best solution of face-to-face instruction, face-to-face learning. So you combine according to your needs in a professional way, in a scientific way. So you integrate the advantages of e-learning with some aspects of traditional methods and brings traditional physical classes with elements of virtual education together. You're already doing this. You have your lecture notes on the internet so that your students can have a look before coming to the class, or after the class they can review the materials. As much as you have the quality material, the results are more successful. And the learning is more effective and meaningful. But the quality of the content is very important. Engagement issues is another important thing. And readiness is another issue. Learners are ready, instructors are ready, materials are ready, and the technology is ready. Then you can talk about successful e-learning solutions. Let's look at different social networking tools. Mostly we are familiar with Facebook. And Facebook changed many things. I am not trying to promote Facebook, but they did something really changed many people's lives, especially for the people who are disabled. They feel themselves more engaged with the society by using such tools. And believe me, when the business world try to understand, try to figure out how many people are using internet, Facebook changed the number a lot. Because before Facebook, the number of people who use internet and the internet users number were different, but after Facebook, they increased a lot. So for many people, believe me, when you talk about internet, they associate with Facebook. Facebook is internet for them. And internet is Facebook for them, nothing else. They use the internet only through Facebook, nothing else. This will change, of course. But it is something new, but attracted many people. That's important. So this attraction can be also used for motivating students. And there are others. Maybe you know this in Finland, and this is another one. In Australia, social networking site. And when you have different solutions, you can use them to construct social learning environments. We are social creatures, and learning is a social activity. That's why social platforms, social media is very suitable for learning purposes. You have the chance to communicate with more people. You have the chance to ask your questions, get answers quickly. You have the chance to enlarge your network. Feel free. There are students who are really asking more questions when they are on virtual worlds. They communicate more, they write more, they ask more. I would like to mention about my experience during my course. I give the course web programming for the first year students. Before, I was giving lectures, and this course is designed like theoretical courses in the classroom, 3 hours a week, and they spend 2 hours in the laboratories, computer labs, to apply what they learned. But I added also some seminars, 1 hour seminar during the week. I invite experts from the field. They are mostly the businessmen owning the company in the Technopolis in our university. And they develop and sell product, web programming. So they come to classroom, I record their speech, talk, and then upload that video to the internet, and they have the chance to review the talk, watch it again. And I also created a closed group on Facebook. All students are enrolled in the group, and also I invite those experts in the group. And additionally to those activities, all students have the chance to write their questions. on Facebook, they ask those experts immediate answers. And they share what they have, they find in the internet through Facebook. As much as they share, they are more curious about the topic. Because the background, they come from different backgrounds. They are first-year students. Some of them, they have some idea about HTML coding, but some of them, they didn't hear about HTML at all. So I also applied a different approach, and I call it as mentorship program. So I find the ones who know a little bit about HTML coding through pre-tests. So I ask them to behave like a tutor and help their friends in the classroom who has very low-level knowledge about HTML coding. So they help them. They also share their knowledge and experiences through Facebook, and they got more information from the experts. And then I ask them to complete their projects, really good quality projects at the end. So using Facebook help them to motivate for their motivation and help them to reach to the experts in the field, and that's more interesting for them to see the real business side of the applications, and help them to be more active in the learning process. So they found Facebook very useful. And also we made another research to see if this is the case for others, and try to understand the results published by different researchers. And we collected different articles published after 2003, especially using social media for learning purposes. And we organized and eliminated some of articles. We kept the research papers. And we made classifications for teachers. They used adult learners in companies for training purposes, and there were research papers for sampling from university students, and there were samples from K-12 students. And the results show that reliable and consistent instruments have been developed, but they are needed to be used in more settings. So in the research, we need more instruments to collect data. And learners show a higher success rate in terms of their grades. And online communities do not form naturally, but users will continue to contribute as long as they are satisfied. That's interesting. And there are some local social networks, and while they are not as common as the more known ones, they have great potential. That's why we see some early examples of corporate social networks. They use social media for their own purposes. They ban Facebook, but they create and develop their own social media. Social networks for K-12 is interesting. They are also using technology, somehow preparing them for the 21st century skills. And studies also for university students, we can say that positive outcomes from the use of social networks. And integrating social media to formal education is a bit problematic. You have to be careful. Your design is very important. How you manage the technical issues is very important. They are more effective as informal learning environments and providing social support. I want to continue with adult learners. and they are used as mediums for tacit knowledge flow. It's very important to convert tacit information, tacit knowledge into explicit one. Now the corporates are behind this idea. And there are some solutions introduced by Takuichi Nanuka, conversion of tacit knowledge into explicit one. You know, in explicit knowledge, it's very easy to document and transfer it. But the tacit knowledge is the biggest part of the knowledge that we have. So through socialization, you have the chance to share the experience. And teachers cannot build social networks naturally, but can use them in establishing and maintaining meaningful connections. And as a conclusion, I can say that Web 2.0 is promising a lot. Different applications are useful for us, and we can use them for educational purposes. Significant innovative learning solutions are expected through adoption of Web 2.0 in the near future. And social media, of course, enhances peer interactions. So this can bridge diversity in the classroom and establish open lines of communication between students and educators. Social media also facilitates discussion and knowledge transfer between students, creating a deeper sense of understanding of the course material. So you have the chance to go deeper discussions. This is very important. You can provide more information beforehand to your students through online materials, and then you can use the classroom discussions for deeper understanding and help them to understand in a deeper way. So students who use social media are able to move beyond the memorization of material and create products that represent their own voices. They are more productive. This also provides some channels for improving their creativity. You know, creativity and innovation are the keywords for this century, and establishing knowledge economy. In the future, learning will be closely linked with people's identity. We are talking about customized learning solutions. More flexible learning environments that provides independent of time and place are required. And virtual classrooms and mobile learning provide this independence. That's why they are powerful. And as we mentioned about mobile technologies, some researchers are combining and taking the term mobile learning under e-learning, m-learning, whatever it is. But I know that mobile learning, m-learning, e-learning, and knowledge management will converge to each other soon. So it's not going to be apart from other solutions. It's going to be considered under the term learning itself. So the E at the beginning will disappear somehow. So for future learning, we have the early attempts and new technologies. When something new was introduced, we are trying to adapt it for teaching and learning purposes. Sometimes they are successful, but we need more research on that. And more results will help us to build more innovative learning environments. And this is the power of mobile devices. They enable the teacher and students to utilize computing power anytime and anywhere. Anytime, anywhere learning is very flexible for all of us, not for young people. And the internet, wireless technology, will continue to develop and provide and introduce new solutions. And recent studies suggest that the advantages of using wireless technologies and mobile devices in learning environments, including enhancing availability and accessibility of information networks, engaging students in learning-related activities in diverse physical locations, supporting group work on projects. This is very important because they gather and they discuss. They develop projects together, and the collaboration is not easy. And we talk about online collaboration today, so we have to prepare our students for the future. So I have some recommendations for ending my presentation. We are sure that there is a need to integrate social networks into formal education. We have to find clever solutions. Educators should be prepared to support students and be active participants in the collaborative learning environment. And educators need to recognize the potential for distractions that's associated with certain types of social media. Organizational social networks should be calibrated for better performance. There is a lack of relevant content that would target the effects of social media to desired solutions. And social networks should be used in wider and more varying environments, as well as for a longer time to better understand their mechanics and effects. So as much as we use the research results will help us to shape the new environments. And the new environments will be more colorful and rich, hopefully, for future students and future learners. So I end my presentation here. Thank you very much. And if you have any question, you are more than welcome. Any question? Yes, please.
I have a question. You mentioned that you use Facebook for education. Do you mean it is for organizing learning activities related with learning objectives? And is one question. And another one, what you think about that 3.0 future?
Yeah, the future is Web 3.0. We expect, of course, we talk about semantic web, but now in the morning session we also discussed about Internet of Things, and we are, when you look at the development related with Internet technologies, new things will appear and we will be surprised more in the near future. And if you ask me about the future of Internet, I can say that Internet is still a fetus. We say that Internet was born, and it was born in 1993 in Turkey, but to me, still is fetus, because when you give a birth, the baby should cry, and the Internet still trying to give some hurts, but not much pain, and the regulations are not ready yet. And you remember the example was very nice in the keynote speakers mentioned about the driverless cars. If they are hacked by the hackers, we will see that we are in trouble. So we are not ready. So the technology is developing very fast, that's true. So we should also be ready in terms of using the technology effectively. And for the Facebook, I can say that you have to, again, be careful. You have to match your learning objectives and using Facebook. And I think you are asking about this. How do you match the learning objectives and using Facebook in the learning environment?
The question was, are you organizing learning activities related to learning objectives?
learning objectives or learning objects?
Learning objectives.
Learning objectives, okay. The activities are, of course, matched with learning objectives. Yeah. Like developing projects, the classroom discussions. And you have to inform your students about the schedule beforehand. And they should know how much they focus on the activity and produce the project at the end. And then evaluation rubrics are according to what they had done through the semester. Thank you. Yes, please.
Related to this, don't you have a problem of identity? And then, because of the virtual world, you can be like anybody. You can know something, or at least you can tell that you know something that you don't know in the real life. In the same way, you are something that you aren't in the real life. So, what is the correlation in reality? Because in the virtual world, you are not sure if you, for example, like giving a class and then examining the results, if that person is really that person he's claiming, because you have no means of physically checking.
Yeah.
And then you have a problem of motivation as well. Are you sure you want to go back to the real world and do the boring living part, or do you want to stay there?
Yeah.
Can you comment on that?
Yeah, that's correct. And that's the hardest part for today. Because, you know, we talk about online exams. That's, again, a big issue for cheating. You are there, and that's why they put cameras and other things, and they follow students what they do, and they want to be sure that he is the person that is doing the job on the virtual world. There are many ways to manage this, to find a solution, but these are the beginnings, still the beginnings. That's why I called I associated internet birth and not still it's a fetus, because remember, for the humankind to find a solution for constructing ships to go through oceans, it took 40 years for the humankind to find a solution, because before steel ships they had the wooden ship. And when the first time the steam engine was introduced, they found the idea that why not to put them on our ship so that we can travel through oceans and discover new lands. And they burned, of course. When they put the steam engine, they burned, and they tried again and again, and they found that we have to change the material. So this was the transformation for them. And they built steel ships and they travel. So the early attempts are really problematic at the beginning. So we are still at the very early attempts. These are the early examples. And I'm sure in the future we will solve all the problems, and we will not talk about cheating or is this the person or not. So we will be sure that he is the person, or he is the one that we are trying to follow. But again, we have to establish the necessary mechanisms and good examples. And I believe that another potential of these new technologies is people try to discover, humankind try to discover himself or herself better with the technology. So in the future, I am hoping that we will be living in a better world. Thank you.
You have recommended to use social media for learning, for teaching students. So you are comfortable to recommend this for any subject, or this is some subject that cannot be learned like this? For example, do you have an example for how to use social media for statistical teaching?
Yeah, you can use. For statistics, the topic is very suitable because the students can find really good examples, other examples, more examples, and they can share, they can also discuss. This is not subject free. That's why we recommend blended learning, not only online learning for different topics. And that's why this is always a joke. Would you get on the plane that the pilot was trained fully online? Although we believe that simulation programs are very good, but still we have the face-to-face classes for pilots and for everybody. So you can blend. As I told you, these are the early attempts, still early attempts. So if we find a better solution, then I'm sure it's going to be for all other subjects. Yes, please.
You were talking about the advantages of this subject, and of course I agree with that. But have you studied some disadvantages?
Yeah.
Because there are a lot of them, and for
Yeah,
instance,
sure.
we also use at our university blended learning and flexible learning, and students complain, for instance, stress, because when they are using Facebook, they have been logged all the day, because someone is writing, you have to follow, so it's very stressful.
Yeah.
So it's just one of
Yeah, sure.
risks or
This is one of the
disadvantages.
disadvantages, and there are many other disadvantages. And using technology, in fact, has got disadvantages. For kids, they sleep with their iPads on their hand. Is it good? Is it bad? I'm not sure. Because psychologists say that you have to limit the time that you spend on the screen. If you look at the if you look at our structure, body structure is not so much suitable for following everything on the screen. That's why this is also harmful for our health. Using mobile phones, they say it's harmful, but we still use it. I'm sure, again, I believe that we will find solutions. But in the near future, also they talk about bionic people. So they integrate the technology on their body. Maybe you know the person who is color blind person, and with his third eye, he listened to the color of the object with the sensor. And the number of people who integrate the technology on their body and they integrate themselves to the internet will increase. And in the future, I'm sure it's going to be much more different things will happen. Yeah, thank you. Any other question? Oh yeah.
Still more question about master program online courses. I know that you are deep in e-learning. Do you know how many courses you have in your university, master program online courses? And what platforms are you using for design of these courses?
Yeah. We developed first online program, online degree program in Turkey years ago. And we, as a university, the administration decided to use the technology, online learning, as a supportive tool. So we have also another program, work-based learning programs on the topic of e-learning, e-health, and e-business. And we have an online degree program in informatics. And the rest is in a supporting manner. So we developed our own learning management system years ago, but then we found that it's much more cost effective to continue with Moodle. So we have the customized Moodle system at Matthew class system, we call it. So all students are enrolled during their registration, and the instructors are assigned to the course at the beginning of the semester, and then you are comfortable to upload your materials, share whatever you have with your students, and students can communicate through the system. And Also, we have instructional technology support office, so that they help instructors to upload their course onto the Metu courseware system. So we have an open courseware system in our university. And we are also working on MOOCs. So we develop much more courses. If we have any chance, then we will continue. Thank you. Thank you. So please, you can get my ID card here, and feel free to contact me for your other questions.
Thank you very much.
Thank you.
This is a certificate.
Thank you very much.
And, a small gift.
Oh, thank you very much. Thank you. Thank you. Thank you very much.
10 minutes for a message and 5 minutes for questions. The first message is of Marek Miloš, the use of steganography to control multimedia players.
I'm the next speaker.
Well, where
from
is
the
Marek?
same university. Because he wasn't able to get to the conference.
Strange. Okay, second message of Marcin Badurovic.
But I can say Dr. Marek Miloš's presentation because I have it here.
You two times still make presentation.
So I can still say it.
Firstly, instead of Marek, then instead yourself, yeah?
Yeah, okay.
Fine, so Marcin Badurovic.
Badurovic, there is a mistake.
Mistake?
Yeah, only there's a row, there's additional row.
I understand. I was trying so hard to read.
I'm so sorry.
Okay, so the use of steganography to control multimedia players, please.
Okay, so good morning, ladies and gentlemen. My name is Marcin Badurovic, but this presentation is from the Dr. Marek Miloš and Dr. Grzegorz Kozer from my university, but they weren't able to get to the conference, but hopefully I know a little bit what is this about, so I'll be able to talk to you about the use of steganography to control multimedia players. Okay, we'll talk today about the new method of player control called SPCV1.
That was correct.
Okay, thank you. About the control data, about markers and algorithm of player control, and about multimedia signal processing. Our object is a typical multimedia player, which means we can use the audio steganography. The audio steganography is embedding secret data in an audio stream. We will be adding additional data directly to the sound data. This is not the additional stream. We are hiding data in the stream itself. Potential possibilities to save user preferences of a control player. For example, volume, speed, some equalizer parameters. And we can hide it directly inside the multimedia data. In the result, we have a stream which can control the multimedia player without any additional information, I believe. The aim of the paper was to present a new version of steganographic player controls, SPC, version 1. The previous version, called version 0, was published a few years ago. So there are two ways to put control data in the multimedia stream. We can attach control data to the end of the stream, or we can place directly within the multimedia stream, hiding control markers inside the container. The second way was chosen as a more flexible. It was used by the steganographic method called the least significant bit, which means the data is hidden in the least bits of the data. In the comparison with the previous method, the SPC1 has reduced size of markers and also removed the timestamp from the markers. This gives us two interesting things. It gives us a possibility to increase number of control markers in the multimedia stream with the reduced size. Because if size is growing, the problem is maybe the data itself will be a bit modified by the hidden data itself. There is also marker collision prevention. The problem is without the timestamp of the marker, the multimedia player does not know position of the marker, which means we need to play the string to find where the marker was. There is a number of various length sequences have the same bit values. We are using in SPC1, we are using 16-bit sequences. So this is one this is one of the most important things. The maximum of length was not defined. In the SPCV version 0, it was 32-bit. Marker length can vary according to the code and the code parameters, because there are different orders you can attach the string. Like, for example, setting volume is only a few bits to set what the value of the volume will be, but for the equalizer, it will be a lot more data. There are 8 possible codes and 8 possible controls you can use in the SPC version 1. So we can control volume, we can control equalizer, we can control volume and equalizer. We can place a go-to marker, which means our player is on the when it finds such, it's jumping to the another players. We can control brightness, saturation, or everything if we need. Or we can also have a possibility to insert a fragment of another order. The least significant bit, for example, when the sound frame has 8 bits, there are samples one after another. The least significant bit is used, and the important thing in the steganography is when the least significant bit changes, user may not notice it because of our ears are not perfect, so we are hopefully working that user may not notice any additional data. There is a very similar thing is when you are hiding data in pictures, so you can hide it in one bit of the blue pixel, and the blue pixel is the worst for us to recognize 2 shades, so it's a great way to hide some data. With volume, we have 8 bits for parameters. With equalizer, there is 40. We go to 18 the possible bits to place timestamp to jump to. The algorithm of marker finding is that we are starting from the sample 1 because this is hidden in the separate sound frames. So to find, for example, 8 bits data for volume, you need to read 8 next frames, sound frames. We are setting the ones counter to 0, reading the least significant bit of the current sample. If it's 1, we are increasing the counter. If not, setting it to 0. We are checking if the counter value equals 8. If so, the marker was found. We are going to the point 5, read the order code, determine the marker structure and length, and do something. If not, we are going to the next sample and going back to the point 3. So if there are 8 frames one after another with ones, we are going to point 5. We are reading the orders code, determining the marker structure, reading all the parameter values, applying the orders, setting counter to 0, and going again and again and again. The insertion is showed on this flowchart. I probably won't be diving into because of the time constraints. But the most important is this new method, SPC version 1, has a number of improvements in comparison to the previous method. Most important are the marker size reductions by the removing timestamps, which gives us also greater capacity and smaller interference introduced into the signal. Smaller interference is pretty nice because the user is not even able to find the signal has been modified. The proposed solution can also be used to change a device's state. I would like only to notice I am not an expert on this topic because I was chosen to tell about it only a few days ago, so I wasn't able to read the paper thoroughly, so please don't ask very complicated questions.
Are you saying that you don't want questions?
If you would be possible, yes.
So maybe we could multitask you. Thank you for the message. Now,
Now
second
it's
message.
my presentation.
Identifying road artifacts with mobile devices.
Okay. Okay, so again, my name is Marcin Godrowicz from the Institute of Computer Science and Lubin University of Technology. Along with my Professor Jerzy Montusiewicz, we are working on identifying road artifacts using mobile devices. We are working on a system to determine the road quality using mobile devices and to publish those road quality information to all users who may be interested in if the road ahead of them has a good quality or not. The road quality is an important factor when we are talking about the road transport security, because with low quality roads there is a possibility, of course, for accidents, but it's not the most, this is not the main aspect we are working on. There are also technical problems of surface management which are not interesting for us because we are working on mobile devices and we are only saying about possible users. The important thing for us is the comfort of the road user. So if the road is smooth, the user is happy. If not, there may be some problem. In the title of the presentation and the title of the paper, there is the word artifacts. So we are finding road artifacts. And the most important question I always ask, what are the road artifacts, of course? So the artifacts are the things which are negatively impacting road quality from the user comfort perspective, of course. And they are potholes, for example, speed bumps, railroad crossings, and everything which can make your driving less comfortable. I'm not sure what is the country of this road, but I hope this is not Lithuania. I thought it's somewhere in the internet. The objective of our study was to find the position of such artifacts, potholes, speed bumps, railroad crossing or something, and provide the map of them available to users. For example, we are using, of course, the GPS device in a moment. So we have a mobile device mounted in a car. This device is equipped with accelerometer and some other sensors. Mostly accelerometer because it's the most important for us, but it's not the most important thing. We have a thing called global coordinate system because the accelerometer returns acceleration, for example, vibration from the road on the mobile devices, but relative to the device position. And the user can place his device in a totally different ways, because someone may have some mobile phone holder. I'm not using a holder, I'm just lying it somewhere. So the global coordinate system is a possibility to map acceleration data into global X, global Y, and global Z, where the X is north, actually, Y is the axis relative to going to the east, and Z is the axis going up from the Earth surface. So this is achieved using not only accelerometer but also a gyroscope and a compass, which are hopefully available in our mobile devices. The method for finding the artifact is a simple just holding at this moment, which means if vibrations over a threshold mark this as a possible artifact. We've made a software. The software is performs acquisition of acceleration data, but actually it performs acceleration data in the local coordinate system, in the global coordinate system, some GPS additional information like the position, speed, course, and GPS accuracy, and time, if I remember. The sampling frequency was chosen to be suitable for slow roads. It is a test study, it's only a prototype, so we've chosen that there are something called as slow traffic zones with the traffic limit of 30 kilometers per hour, and we were making our study on that kind of roads. There should be a possibility to mark artifact by the user using driver. So we have a driver, there is a mobile phone somewhere, and when he is entering a bump or a pothole, he is saying now, and I can, after driving, compare what the user was saying and what the accelerometer was saying. And of course, this data needs to be sent to the computer or some kind of web service. The software looks like this. It is probably the most horrible software user interface you have seen. So there is a start and stop, of course, to get some information. There is a very big bump button, which is marking the position or the current position as the position of a possible artifact found by the user, and a lot of diagnostic information. This is not final version of the software, of course. The final version presented to the real users will be a lot more user-friendly. And we are gathering data of acceleration in X, Y, Z, Z2. This is in the global coordinate system. Acceleration in north and east, so after conversion, the current time, current latitude, current longitude, and a few things were added because this is version 0.5 probably, and the current version is 0.7. And this is put in the observable collection, so I will not dive into details. So we are acquiring some data. We are calculating mean and standard deviation after, of course, transferring to the computer. We are thresholding, placing artifacts on a map, placing user contacts on a map, and checking who was right. Such systems exist. There was a study from the Microsoft Research with NERIS and traffic sense system, where they had a smartphone, GPS receiver, and external accelerometer in 2008. But it was in 3 devices. I have everything such this in one device. There was a great system called Pothole Patrol in Boston, mounted in Boston taxi system in 2008 by researchers from MIT. In the comparison, our system is built with the global coordinate system. They were using only local coordinates, and their system was using all data from all 3 axes. We are concentrating on the only data of acceleration of going up and down in the global coordinate system. There was a prism using values from 3 axes in 2010 with 35% of correct identification of potholes. There was a study by the Pertunen in Finland with a frequency of 38 kHz, using GPS the first time, and the Kalman filter to remove noise. We are not using the Kalman filter to remove noise yet, so there is a lot of noise. And it was a very interesting solution because it was very similar to ours, a system called Wolverine, which was based on the standard deviation of vertical acceleration. So it's a very similar thing to us, but they were not using the global coordinate system, but were using Euler angles. And they were not concentrating on potholes, but on traffic smoothness. So how the driving over a speed bump looks like. So there is a car. And there is a speed bump, for example. This on the right, this is a big made of concrete. The left one is made only of rubber. When we are traversing a speed bump, the acceleration in the z-axis looks like this. So you can see the data in the x-axis on this graph is in this figure is in G. G is 9.81 meters. So it's Earth accelerations multiplied, and there's the time. When we are traversing, when we are traversing, we have here some going up and here going some down. This is when my car is going up on a slope and going down on the exiting slope. And there is the second pair of wheels, and there is something. This is data from the additional pothole, because there was speed bump here and the pothole just after another. Using thresholding, we need to calculate standard deviation. If it's lower than, if lower, then the road is called, it will be more smooth. Multiplication of standard deviation will be a threshold, which means overall state of the road is not important, because we are valuing how the road is rough, and if it's rough even more, this is probably a pothole. So how to calculate the threshold value? We've made some experiments. So the first experiment gave us 1,167 samples of data, 10 times a second. The average acceleration was minus 0.94, the maximum was minus 0.58, the minimum was minus 1. If you are just going minus, because the Earth is going, the Earth acceleration is going to the Earth's core, but the axis is up from the Earth's surface. There were 8 artifacts, speed bumps, in the road. And using different values of threshold, from the 3.7 times standard deviation to the 4.5 times standard deviation, we found artifacts from the number 24 to 12. So the real number was 8. The correct value is somewhere between 4.1 and 4.3, because with 4.5 we have not found every artifact on the road. But why this is still greater number than the real number of artifacts? Okay, one more time. The first pair of wheels, the second pair of wheels. There are 2 possible artifacts detected for every real artifact. And we've made some visualizations. So, okay, so there should be roads. You don't see roads here, probably, but there is a road near my home with speed bumps. 1, 2, 3, 4, 5, 6, 7, and 8. And you can see the red diamonds, other places where the user pressed the bump button. And the green push points, other places where the system said, here should be an artifact. So in every case, except the number 5, there are 2 push pins for every real artifact, which means I found the artifact 2 times because going up and down. We've used the same system to find another times of artifacts, not only speed bumps, going through some streets, from the Muzyczna Street, Szczegowskiego Street, Dondola Primary Streets in Lublin. Here are very interesting 3 push points, because the system said there is an artifact here, there is an artifact just after another, and one after another. This is a place where the road surface was so degraded that you are going up and down constantly. And here is pretty interesting artifact where it found three artifacts in one place. Actually, because of there is a very, very extreme hill going from different levels of the streets. We've made a second time going with the another user, so the driver was not interested in checking bump, but only the passenger was checking bump, so for security reasons, for safety reasons, and the results are pretty similar. With the work with this degradation here and here was also marked by the expert as the most artifact found. So, going to conclusions. Today, for our system, the sampling frequency is 10 Hz. So we are measuring our acceleration 10 times a second. While it is nice when we are going slow, the problem is what happens if we are going faster. So we are trying to work on adaptive sampling frequency based on a speed. Our software platforms allows us up to 62.5 Hz. Nice. We are not analyzing this data automatically yet. This data is parsed mostly by this very complicated set of 2 scripts on Excel. So we are working on some more automatic analysis somewhere in the cloud. And the most important thing, we are working on the warning system for mobile users. So you can drive and see warning in front of you. There is something we can say this is a road artifact. Yesterday with my colleague we were driving here at night and there are elevated passenger crossings. We are going 50 kilometers per hour, like I was saying, but still going through the elevated passenger crossing with the speed of 50 kilometers per hour is not probably a good idea. Yeah. So the warning system could be pretty interesting here. Or maybe better lighting, I'm not sure. Okay, and we are working on trying to find the overall state of the road from the user comfort perspective based only on data from acceleration by a device mounted in the car. So, thank you, and we have maybe some questions.
Questions? Yes. But
how do you convert the local system,
the global
coordinates into global?
Yeah, we are using something. I need to find the name. Matrix. I forgot the name. There is a matrix. There is a matrix which is given by the software because it's in the API. From the data of gyroscope and compass, and I know how the device is in the how the device is in 3D space. And if I know how the device is 3D space and know the acceleration of the device, I can multiply my acceleration by the matrix.
It's from Android APIs.
Actually, this is Windows Phone. But with Android, there is the same thing. When I go back to the computer, I can say what was the name of the matrix, but I forget.
Let's consider if you are an experienced driver and let's say you do frequently wrong gear shifting and then you experience trembling, those vibrations.
I haven't checked, but we are working on the only the vibrations going up and down. I'm not sure.
Various vibrations.
But we haven't tested this yet. Okay, I don't know for myself.
Avoid collecting data from this.
I'm afraid of collecting data from this case.
While collecting data, your phone has to be in a certain position.
No, because of the global coordinate system, it could be oriented anywhere and anytime. It is there is only one important thing. It must be stable. So it should not go from the left.
You shouldn't shake your phone.
Yes. And it cannot be, unfortunately, it cannot be in your pocket because it is based on the car movement.
More questions?
Okay, so.
Oh, also one question?
What about size? Can you classify bigger, smaller artifacts?
With the frequency we have, 10 hertz, when you are going about 40 kilometers per hour, I can find the artifact if the power force goes through this with a size of about 1 meter in length. About the depth, I can classify them because with transcode I will find how if it's a artifact or not, and I can still define how much is it over the threshold. But I haven't checked it yet. I have data because we've made a lot of more experiments, and there is one speed bump near my home which is very large, so I will check if it's possible.
What about integrating data from several drivers?
Yes, this is my current goal, to integrate data. Probably it will be based on some kind of a system which is, there is in Poland a system called Janosik, which gives you information about the current road situation and actually where is the police. So the user is saying, here is the police, and probably the same thing will be if made. So this is the goal, to create such a system, not yet.
Okay, thank you.
It is no, thank you. Okay, thank you very much.
Next message of Mehmet Serdar Beshar from the predicting defect-prone models in web applications.
Hello everybody, I'm a PhD student from Turkey, and this topic is about my part of my PhD research. I bet every of us, everyone here, bought something from the internet or did one transaction at least. And this is the general situation in worldwide users, and the 87% of users in North America and 70% of the Europe use internet today, and the annual worldwide total of internet-based transactions has reached trillions of dollars. But in such a big industry, there are problems. For example, 70% of the commonly used websites still have problems that is visible to end users. And testers use defect prediction techniques to focus on fault-prone modules in testing phase, so that they want to reduce the cost of testing process. And in this search, our motivation was we believe that there are some technical characteristics which makes web applications unique compared to other types of applications, and to the best of our knowledge, nobody researched using these characteristics in defect prediction studies until today. So in this study we have two research questions. First, we want to identify and extract special metrics to the metric special web domain, and then we want to use and evaluate those metrics in software defect prediction. History of software defect prediction goes back to 70s, and the researchers use different kind of metrics to their models, but all of them was extracted from either desktop applications or embedded systems, and none of them considered using a metric set which is special for a domain. In this study, we take a data-centric approach. That means we wanted to improve the quality and information content of data set by introducing a special set of metrics. For this purpose, we took a strategy of inspecting web application error taxonomies to identify characteristics and the related fault classes, and we found 6 characteristics from previous work, and there are 31 fault classes related to them. And in result, we have extracted 10 metrics mapped by 12 classes of faults, and the rest is ignored because they are either impossible to extract metrics with in an automated way, or they are related with client side of projects, that is HTML or CSS. So, and we are only interested with server side part of web applications because our proposed data set is not considered to use alone, but as a supplement to existing static metric sets. So we took 3 projects, 3 open source, widely used and still actively developed web application projects as input to our model, and our design is simple and traditional one. We took source files and code history, and we have some data processing phase. We create our data sets, and we use 3 different classification algorithms with 10 times tenfold cross validation. And finally, we implemented man-Whitney U-test to evaluate statistical significance of our metrics. To measure the performance of the model, we use PD, probability of detection, PF, probability of false alarm rate measures. They are widely used in defect prediction studies, and high PD rates are desirable, but it often brings high PF rates with it. This might be desirable for safety critical systems, which belong to risk adverse region, but it's an undesirable situation for projects which has low resources, because high PF rates means more inspection of unnecessary modules. We also applied attribute selection filter, collection feature selection, to our data sets to see if our proposed metrics can be considered as informative to be selected as best metrics, to be included in best metrics by an attribute filter selection algorithm. And we found that 5 of our metrics, which makes 55%, is selected by feature selection algorithm. So we continued on research, and here are results, PD rates and PF rates. We see that there are some increments in PD rates, but the main improvement is in PF rates. By improvement, I mean there is a reduce in PF rates, which is desirable. We see that proposed metrics have the effect prediction algorithm to reduce unnecessary inspection costs. So PD increase, PF reduce, but our primary measure is balance, which is balance is the distance, Euclidean distance to the base point in a rock curve. Okay. And we see that in 12 from the 18 comparisons, it makes 66% of our testings. We see that there is a statistically significant improvement in balance values, which range from 1% to 12%. And we also see that we got the best reaction with naive Bayes algorithm. We see in all data sets, in every result, naive Bayes with naive Bayes algorithm, there is a statistically significantly improvement. There is one possible threat to validity in external validation. We limited our data sets with projects with single programming language. They are all PHP-based applications, but none of our proposed metrics are special to a programming language. They are special to a domain. Therefore, we think this has low severity. And the main contribution of this study is we introduced a new set of metrics which is domain specific, and to do that we mapped false types of web applications to software metrics, and this resulted in performance gain ranging from 1% to 12% depending on data set or classification algorithm. As I said, we considered server side of applications because we use these metrics as supplementary, and static code metrics are only available for traditional programming languages like Java, PHP, C# or etc. And in future, we plan to analyze client-side web applications, that means extracting metrics for CSS or HTML. Currently, there is no metric for these languages. Thank you for listening. Questions?
Questions, please? Yes, Daro.
As I understand, you are predicting a probability that the application fails, right?
No. We are predicting for each file in a project that probability of fault provenance of that file. So that the practical reason to do this is that in testing phase, testers has to check every part of application, but practically it's impossible. So that they must focus on some part of application, and to choose the part to focus, they need some prediction algorithm, and effect prediction is used for that.
Well, in another practical, well, let's say I'm choosing content management systems, and can I choose between Joomla and WordPress according to your style? Which one is better?
No.
No?
But
in testing environment and testing case.
No, that's not the topic.
Okay.
More questions? Thank you. Next message of Dalia Chalnerytė, dynamic analysis of for-node degenerated shell element with updated thickness. You updated from your last year? No? 5.
Good afternoon. My name is Dalia Chalnerytė. I'm a PhD student at Kaunas University of Technology, and I'd like to introduce you to dynamic analysis of for-node degenerated shell element and the impact of thickness update. First of all, I'd like to start with the formulation of for-node degenerated shell element and updated Lagrangian formulation applied in dynamic analysis. There are two types, explicit and implicit, and finally I'd like to discuss numerical examples and final remarks. Firstly, for-node degenerated shell element is applied in finite element analysis if the structure is if the dimensions in one direction of a structure is significantly smaller than in the others. And any point of shell element can be defined by nodal coordinates, shell thickness, and a vector connecting upper and lower surface at a specific node. Each shell element can be defined by geometry, that is those points, and material properties. In all numerical examples, the material was assumed to be isotropic. The purpose of our research is to know the displacements at each time step and at each time moment, and displacements of at any point of a shell element can be uniquely defined by 3 translational displacements and 2 rotations. One more rotation, that is drilling degree of freedom, is added in order to apply transformation from local coordinates to global. In the initial mesh or initial structure is meshed with flat elements, and during simulation and later iterations, shell elements can warp, that is, they can deform so that all nodes are not in the same plane anymore. So, to correct this warpage, the rigid link correction is applied in our research. To simulate the behavior of structure, updated Lagrangian formulation is applied. This formulation relates second Viola-Kirchhoff stress with 2 green Lagrange strain with strain referred to the configuration at time t. It is assumed that we know all variables at the previous time, at the last time step we know, and we are now computing the variables at the current moment. Usually those variables are displacements or rotations in the case of shell, but we added to these variables, and we would like to update the shell thickness with respect to the area of the element. That is, if the area of the element is increased, the shell of the thickness of shell is decreased. And two integration techniques, explicit and implicit, are applied to simulate the behavior of a structure. But for the explicit analysis, central difference scheme is applied, and buffet scheme is applied for implicit analysis. Central difference scheme is well known, quite one of the most popular schemes for integration. We apply that scheme with the assumption that the time step is constant. Implicit analysis, buffet scheme was applied for implicit analysis. This scheme is quite new and proposed by Professor Buffet. This scheme consists of two substeps. The first substep is the displacements are calculated according to trapezoidal rule, and the 3.0 backward method is applied in the second substep. Newton-Raphson iterations are applied in both substeps to correct the solution. Now moving on to numerical examples. The first example is the in-plane load. The linearly increasing force is applied at the ends of the beam. Only quarter of the structure is simulated in order to reduce simulation costs. With symmetry conditions for the thick lines in the scheme, and here you can see how the shell thickness changes during simulation for implicit and explicit analysis. The chart shows longitudinal displacements at the end of the beam. Of course, if the thickness is reduced, the stiffness of the element is reduced, and the stiffness of the element is weakened, and the displacements reach higher values. The next example is the beam is loaded, the center of the beam is loaded vertically. The force is linearly increasing, as in the previous example. Only a quarter of the structure is simulated with proper symmetric conditions, and here you can see that the explicit central difference scheme becomes unstable, although the phase scheme is stable and can be used to calculate the response. The last example is a pinched cylinder with end diaphragms, and the cylinder is loaded also with linearly increasing force at one node. Here the behavior is governed by rotational displacements, and the change of the area of the element is small, so the thickness also, the change of thickness is also small, and the impact of changing and the displacements are also very similar for both. Either we change the either we update thickness or not. And so this brings me to the end of presentation. As I mentioned before, there's integration schemes. Two integration schemes were used, and in conclusions, what we found in our research was that for the out of plane loads, the changes in element area is small, and therefore thickness doesn't change. It depends on the change. It depends on the area of the element, and if the area of the element does not change, the thickness also doesn't change. If element undergoes large deformations, the stiffness of the element is weakened, and then the differences for the displacements are quite significant. So thank you for your attention, and if you have any questions.
Questions, please. Formulas. We are boring. All. So where can you apply your research results?
Those results can be applied from numerical simulation of constructions. These examples were templates or usual examples that are used in all papers and all articles to compare the results with these parameters. And now we can apply those results to whatever structure we want.
Maybe next time it needs to show less formulas, but more some words I understand. But you like formulas, yeah, I understand. Okay, thank you for the message. And the last message of Audrey's Nachunas: obtaining dispersion curves of damped waves by employing semi-analytical finite element formulation.
Can I have presentation in the next room?
No, you just keep it. Okay, hello to everyone. I am a PhD 3-year informatics student, and today I would like to talk about safe semi-analytical finite element formulation in order to get dispersion curves. This is a little bit different topic than I have heard here, so please bear with me. Stay focused. Okay, so I would like to talk about acoustic waves at the beginning, and then finite element and semi-analytical finite element methods, modes and dispersion that would characterize the waves. I will show you numerical results, and I will include final remarks. Okay, and then we will have a discussion later on. Okay. So now, in recent years, ultrasound has become very popular in non-destructive testing as efficient technique. And I'm I'm imitating a waveguide that has aluminum properties, and it has a square cross-section of 1 centimeter and 1 centimeter. We have a scheme that shows you how the ultrasound is being produced in the waveguide. As you see, we see the transducer here. It invokes a longitudinal wave that would enters the waveguide, and then it reflects, and on the same time it generates shear wave. And the shear wave also reflects from the inner wall of the waveguide, and also reflects and also generates the longitudinal waves. And those waves interference with each other and then transforms into traveling wave. And as we see here, back, and that wave starts over here. Okay. Then, so in this scenario, I would like to use semi-elliptical finite element methodology for modeling that ultrasound wave. Now, SAFE requires just a discretization of cross-section of that waveguide. But I have to make sure that the square in the cross section is the same along the waveguide. And if we look here, we see our wave equation. Then it's written using SAFE formulation. Now, this vector represents the shape of the square, the cross section, and now that exponential term describes the harmonics of that wave. And I'm using notations of angular frequency, wave number, and phase velocity. Now, you may not counter it with the wave number. That is inversely proportional to wavelength. And I think we can go next to the next one. So when we model our traveling wave through a waveguide, in this situation we have a flexure mode invoked, but still, if we have no damping, so I'm not getting any decays in the time and in space, and in that situation, I'm having just attenuation, damping in time domain. Here I'm having attenuation in space domain, and both are put together. Now I'm dealing with this situation and with this situation. Okay, now we start from the dynamic equation, and it has a general solution. Now M stands for a mass, C for a damping, and K stands for stiffness matrices. Now, as you see, U with a double dot means the second derivative, the first derivative, and U means the displacement vector. Now, the general solution has this form, and as we talked earlier, this kind of form is slightly different in SAFE formulation. Now, the cross-section discretization is being made using these formulas. Now, maybe I would like to tell you more about maybe stiffness matches B1, B2, and B3. K1, K2, K3. Now, K1 would describe the formation strain in plane cross-section. Now, K2 would mean out of plane deformation, and K3 would combine those effects into one. And so finally we construct, having those elements, and we construct our matrices, and let me go better. And finally, we construct our general eigenvalue problem. And now I'm applying damping matches as you see here. So it is proportional both to of mass and stiffness matches. But for the sake of simplicity, I would use here just an alpha coefficient. So I mean that I have damping matrix that is proportional just to mass only. Now, I'm expecting to get two relations possible. Omega is a function of k, or k is a function of omega. But I will deal with both of them in respect with my expectation. I will talk about it later, okay? And if I'm dealing with the second relation, I would have to modify our primary eigenvalue problem into this one, okay? Now, okay, may proceed. Now, while solving that problem, I can get two different results. Now, if I see some omega as a function of k, I get these results. Now, these are called dispersion curves that shows the relation between circle frequency and wave number. Now, these are the main characteristics of any wave used in ultrasound testing. You know? Now the other solution, when omega is our freely chosen argument, as you see, I obtain more results. These curves have been obtained by using 9 elements in the cross section. Now, there are results involving even those modes that are not propagative. I mean, they are N nodes and evanescent modes. That mean that they are decaying, and the others are the propagative modes that are similar between those two results. Now let me go further. Now I'm skipping these kind of Ks because they are they physically don't exist, and I have to deal with K values that are of such shape. Now we can go further. Now the other way of showing the results is presenting phase velocity. Now here we see the results that agree with theory pretty well. Now I have marked out 3 fundamental modes that exist. It's longitudinal, torsional, and flexural. In acoustics, they usually use, even all of them in this in respect to the given problem. So, and as I said, those results well agree with the theory. Okay, proceed now. Now I was experimenting with the impact of alpha to our damping matches, and as you see, the effects of an alpha for the dispersion curves. Okay, we may go further. Now these are results for group velocity. When the damping is absent, it means the energy, the speed of energy in the waveguide. Now once again, we see different modes, but when the damping is present, we will have to use an energy loss velocity, but I haven't included that in this article. Okay, we may proceed. Okay, and so the final remarks. This safe methodology offers an effective way of modeling wave motion along the constant cross-section geometry waveguide. And it also worth reminding that the layers having different properties can be included in the waveguide as long as they are parallel to the wave propagation axis. And while effectiveness of safe method is relied on eigenproblem. By the way, I was using MATLAB for solving this problem. It is obvious that we have to avoid singular matrices included in our eigenproblems. So in near future, I'm planning to experiment with coupling different elements. That one element would describe the fluid, other the waveguide, and I would have to model intersection between those two different mediums. So, and that would be final remarks for me. And can we go to the questions part then, I suppose?
Yes. What is the practical value of your research?
Okay, first of all, you can model model the methodology, or maybe you would model the future frequency for the transducer. Okay, you will have to see what frequency you should use for doing experiment in the real life. You will just model the results in the computer and see, oh, okay, I will use this mode, or maybe that mode, and it will give me the best results. No, it saves you money, okay, if you do the modeling before test, real test.
And wave motion is important
in inspecting non-destructive testing. You know, when you're looking for cracks, you know, in the material, for example, in a aircraft plane, you know, when you see the crack, you have to change that that material that you need. So, yeah, or inspecting any material that has to be without the.
One questions. I have very important question. Which year are you PhD student?
The third one.
Third one?
Third one, yes.
Okay. More questions? Thank you. That's a good for you.
Thank you.
So, thank you for attending. That's all.
I want to say thanks for chairing this session. Thank you very much.
Sorry? But for me, was information that you are not present?
Well, I mean, we registered last week, so it wasn't a delay.
Okay, so you can proceed.
Sorry.
Excuse me. Do you have here?
Yeah, it's there. I was a little bit puzzled.
So why you escaped registration?
So there was some problem with funding from our university. So my professor, Christian Reimann, was trying to settle this, and it wasn't clear if I could attend or not.
Oh,
that was the main problem. Because I can't afford as a student to come here at my own cost at all.
Okay, so introduce yourself.
Sorry?
Introduce yourself for all of.
So, good afternoon. My name is Matthias Meidinger, and I'm kind of delaying it a little bit, maybe the end of this session. I'm a computer science student from the University of Applied Sciences and Arts in Dortmund, and I will present you my work, ErrorFX, native themes for JavaFX. So, in fact, I do have a not working presenter. Great.
Well,
this way.
Okay. So my work is settled in a little bit different area. My work is basically concentrating on design and user experience. Usually these two go well together, but sometimes, as in this case, they don't. So basically, The motivation is JavaFX is the successor of Swing, which was the standard UI toolkit of Java for more than 16 years. And JavaFX is rather young with its 2 years. So basically, Swing offered you cross-platform and platform-specific look and feels, whereas JavaFX to the day only gives you platform-specific, gives you no platform-specific look and feel. So we have the need of platform-specific look and feels, which means basically that an application blends in with the operating system it is run under. So the design itself is defined by the operating system for native applications, as in C or C++ or general.NET for Windows. And the layout is defined by the developer, which means how the buttons are arranged or how they look, how they react. That's usually a thing that's more defined by the developer. And the third thing is the user, which has experience and expectations while it uses software. So usually the user, or many users today know Windows, so they know the look and feel, how Windows behaves when I use it. So when they are confronted with a new piece of software, they are kind of used to that, as with driving your car. Usually you know which gear is where. So that's what you expect, and that's why they say the first impression always counts. So you have the inner consistency of an application, which is basically, if I press the save button in the submenu or press the save button in the toolbar, it should both times do the same thing, basically. And you have the outer consistency of an application, which is seen versus the surrounding operating system. So that's it. Concentrate on the task, not on operating the software. And which means consistency ultimately gives you ease of use, a relaxed user, and a relaxed user is more likely to use your software again, basically. So Oracle announced that they do not develop platform-specific skins, but stick to one cross-platform skin named Modena. And RFX, stating the name of my work, basically provides a skin with native Windows 7 look and feel. So, yes. As you can see, this is Modena. This is the computer settings rebuilt for Windows 7, rebuilt as a JavaFX application, and this is the standard or default JavaFX skin. So it looks like this on all platforms. So you see that the buttons look different, the tab bar looks different, and so this was my starting point. And then on the next slide we will see the target platform, which is Windows 7. One could ask why I still stick to Windows 7 as there is the dawn of Windows 10 now. Thing is, many companies in Germany still are migrating or using Windows 7 right now, so they don't plan on migrating in the near future. So Windows 7 still is extremely well distributed in among German companies. And there is always the big thing of running older applications or migrating older applications from Windows XP to Windows 7, which is taking place right now. So usually the companies don't want to spend more money to migrate to Windows 10 again, at least not in the actual future. So we can see usually. So that's why I stick to Windows 7 mostly. And what we will have a look at is we see some of the design elements, which is a tab bar. We have next one. Yes. Then we have group box, which groups several elements. Then we have radio buttons that are also grouped together, and we have the different states of buttons in Windows. Most of you probably never noticed, but that's a thing that users usually kind of feel, they don't even see it consciously, but they feel that that it's behaving different. So JavaFX, as a successor of Swing, is basically an UI framework with even multi-touch support, and is they are working on implementing it on iOS and Android too at the moment. And one of the specialties of JavaFX is native packaging. So you can package a runtime environment to your application, so there is no need for Java on the target platform to be installed. So, but because of time constraints, I think we will skip a little bit of this. Basically, you can see that the JavaFX application consists of XML, which is used for the layout, CSS, which is used for the style, and classical Java, which is used for behavior and more fine-grained control. Yeah. So there is some work, some people out there that tried to develop skins for Windows 7 or in general OS X or other platforms, but to just tell you real quick, JFX native themes, or most of them suffer of unclear licensing, and they lack functionality. So most of them are just proof of concept, as it is with JFX native themes, as well as the next one, which is JMetro. Basically, that guy is developing its skin through a Dropbox share, or distributing it through a Dropbox share, and he also concentrated on Windows 8 and Windows 10 look and feel, moreover. So there is one project which is AquaFX, which is developed by a fellow Dortmund developer, and she concentrated on Mac OS X. So I took her project as a starting point and kind of oriented a little bit some of our design decisions to it, especially the license, the type of distribution, and for example, realizing it as a Maven project, so it has easier dependency management. So the basic architecture of skins in JavaFX is you've got your JavaFX API, which has, for example, a button. This button has a skin. Then there is the my skin, or in general the skin you use, which defines a global CSS in the application context. Which then has access. In fact, it defines it here, and then you have your private API where you basically define all the things that, so you try to restrict access to your private API. So the CSS defines an arrow button skin, so it basically names a class that extends the button skin and ultimately styles the button. So it's a little bit complex, but still it's with enterprise in mind. So it should be robust and safe. Yeah. So the study consisted of building set dialog, and as you can see, there is the comparison between Windows 7 native and my ArrowFX skin, which you can see here in the screenshots for a checkbox, as well as radio buttons, as well as buttons in general, followed by the group box, which is implemented, and the tab pane, which you can see here. And final thing is the mnemonics, which are basically they are used for navigating buttons with the keyboard. So the underline under a button. So what you can see here is the target and the start point, which is Modena, the standard skin of JavaFX. And now you will see, next one please. This is, oh, that was one too much. This is the final outcome of my project, or the final outcome at the moment. So you can see that it that it resembles the original dialogue almost one-to-one. So yeah. So the conclusion is most of the related work has some slight weaknesses, especially the licensing and documentation is very often a problem as well as the distribution and the architecture in general. So I ended up with AeroFX clearly equaling or even beating all of the related work in every category. Yes. Could you go on, please? So the conclusion is for me that native skins are recommendable. So go ahead and use them if you ever come to program a Java program. They increase acceptance, and in general, as I said, a relaxed user is more likely to use our software again. Thing is, the project ended up being an enterprise level architecture with Maven support, and it's open source. So everybody who wants is freely invited to help and extend the project. So the main problem is that JavaFX as a relatively young technology is still not finished and partly undocumented by Oracle. And the key to success for JavaFX is the community support, which in turn is increased by projects like this. So the project is not finished because it's still missing some controls. So if anyone is interested, please go ahead. It might be a good idea to join the two projects of AquaFX and AeroFX because they quite resemble each other. They are the architecture is somewhat similar, so that we could join them. All in all, I have to say I had very positive community feedback so far. So I had many visitors on accompanying blog posts describing my the work in progress, as well as multiple inquiries and contacts of different companies around the world, which was very interesting. Yes. So, are there any questions?
So question, please.
So I have a question. You said this is open source, but what license?
BSC, 2+ BSC. So
this is some kind of GitHub project?
Yes. It is licensed under 2+ BSD, which means it's basically open source license, but you as a company are allowed to derive from it and even change it without telling me or without even releasing your changes. You could. Yes.
More questions? So my question, why colors are different? Here I'm almost not seen, but on my screen I see different colors. Blue and here white.
Where exactly? The background of the...
Why backgrounds are different?
Yes, that's because this is on the right side. This is the original JavaFX skin, and this is my my AeroFX skin. So this is the one that's the target, but you can see them. This is the original Windows 7,
yeah,
and this one is mine.
So
this
colors?
is the outcome. So Modena per default uses a gray background color on every dialogue they do.
In order to get difference?
Sorry?
In order to get difference from original?
No, wait. This is not. This is Modena. This is created by Oracle.
I see. Okay. More questions?
So the one that looks horrible is from Oracle?
Yes.
Yes, fine explanation. No more questions, so thank you for your message.
Thank you.
Now already really our session is closed.